Welcome to Brain Vision.
Okay, in this problem, we have two trains passing each other, and we're given a formula for frequency. So f sub 0 is the frequency perceived by the observer, so what we hear. And then c in this formula is the speed of sound, which is a constant, 332 meters per second. V sub 0, that's our velocity, how fast our train is going. Okay, so in this problem, 34 meters per second. Then V sub s, how fast the source of the sound is going. Okay, so how fast is this train going? And it's going 40 meters per second. Let me get those right there. Then Fs, that's the frequency of the source of sound. So that train is blowing its whistle, and its whistle has a frequency of 460. So the first question is, what is the frequency that we hear, or what is our perceived frequency? So f sub 0 equals speed of sound plus our velocity divided by speed of sound minus that train's velocity times that train's frequency, 460, or the train whistle's frequency. Okay, so multiply those out, you get 576.6, and that's hertz, because that's what frequency comes in. Okay, now that's not the interesting part of this problem. The interesting part is this question. What's the rate of change of the frequency? Okay, so at first I didn't know what to do, but then I noticed that they told me the acceleration. So our acceleration, 1.2 meters per second squared, and the source's acceleration, so the other train, 1.4 meters per second squared. So that told me the velocities are both changing, not the frequency. So this 460, that's a constant. So I'll put it right here. So it's 332 plus our velocity, 332 minus the source velocity. Okay, so both of those are changing, both those velocities, and when I take the derivative of the velocity, I get the acceleration. All right, so here I go. The rate of change of the frequency with respect to time is, 460, that's a constant. Okay, I'm going to use the quotient rule here. It's the bottom times the derivative of the top, which would be 0 plus the derivative of the velocity, which is the acceleration, minus the top times the derivative of the bottom, which would be minus the acceleration, as, all over the bottom squared. Okay, times 460 there. Okay, so you get 460 times, this is 292 times our acceleration, which is 1.2, minus makes a plus. 366 times their acceleration, 1.4, all divided by 292 squared. And multiply that out, and you get 4.65, and that's hertz per second. So here's the perceived frequency, and here's the rate of change of the frequency.